Hello all. So in this lecture we'll see about arrays in C. So we'll see what is an array first. So array, it can store a fixed size sequential collection of elements of the same type. So if you want to store a collection of elements, that collection is of fixed size and it can be stored sequentially. And those collection of elements should be of same type. That means same data type. If you want to store 10 integer numbers, so we can use a single variable for that. Instead of using 10 different variables, if we want to store 10 similar integer type of element, we can use a single variable and address all those elements. For that we can use arrays. So it is used to store fixed size sequential collection of elements of the same data type. So it is used to store collection of data. So if you want to store some 100, for example, if I want to store the marks of the students of your class, if you have 60 students in your class, I want to use 60, I want to store the C marks of 60 students. Then by now with this knowledge you have to use 60 different variables like marks 1, marks 2, marks 3, like that, mark 60. You have to use 60 different variables to store the 60 students mark. But instead of that, you can use a single variable and address all the marks. So it is used to store a collection of data. So it is as a array as a collection of variables, can be used as a collection of variables of the same type. Instead of using marks 1, marks 2, marks 3, it can be considered as a collection of variables, all those variables of the same type. So if you want to store 100 numbers or 60 marks, you have to use like this, number 0, like this, number 1. So it is very difficult. When you write this program and all, it is very difficult. If I want to take some person's marks, that mark of 20, marks 20, like that, I have to use some different variable names for different student. So it is a difficult thing. So instead, if we could declare one array variable such as numbers, if we declare some variable like numbers, and if we can address all the 100 numbers, it will be useful. So we can use like this, numbers of 0, this is known as indexing. So this represents the first number. Numbers of 1, this represents the second element. Like that, numbers 99, it represents the last element. So if you use like this type of indexing, you can store. So this is a common variable, this is a common array variable for all these numbers, and we use indexing, numbers of 0, numbers of 1, like that. You can index all those things. So specific element is accessed by an index. We use this index. So this is a thing, numbers of 0, then numbers of 1, numbers of 2, numbers of 3, like that. There will be 100 elements. So last element will be numbers of 99. Okay, if you want to store 100 elements. So you use the same variable name. Numbers is a variable name. But you change the indexes only. 0, 1, 2, 3. Like that you can use the array. So arrays consist of contiguous memory locations. The memory locations are contiguous. So lowest address corresponds to the first element and the highest address to the last element. So for example, if you have a 100 element array, then if the first address is at numbers of 0 is located at 2000, and if it is an integer type or float type, you will take 4 bytes for that. So next will be at location at 2004. So it is then after that, it is not 2006, it is at 2008. So 4 bytes will be used. So number 0 will use 4 bytes, 0, 1, 2, 3 will be used. 4, 5, 6, 7 will be used by numbers 1. 8, 9, 10, 11 will be used by numbers of 2, like that. Next will be at numbers of 12, then 16, like that. Then the last will be at 2396 because each will be used at 4 bytes. So this is known as contiguous memory location. Contiguous means continuous memory location. 2004, 2000, 2004, 2008, 2012, 2016, like that it will go on. And the last element will be at 2396. So it will use 4 bytes and it will be using 2000 up to 400, 2400 memory locations. That is why we say this contiguous allocation. So lowest address 2000 represents the first element and highest address 2396 represents the last element. So how to declare these arrays? So for declaring this array, it is same as variable declaration. So for variable declaration, we'll be using data type and a name will be used, variable name will be used. Here we are inside the brackets, inside the square brackets, we have to specify some array size, some value, some integer value. So this is a single dimensional array. It is a single dimension, only one dimension is there. There are multi-dimensional like 2-dimensional, 3-dimensional, 4-dimensional, like that. Any dimension can be specified for arrays. We will see about multi-dimension and all later. Now we will be studying only about single dimension. Only one array size will be there. So array size, it must be an integer constant greater than 0. So the size should be greater than 0. It should be an integer constant and it should be greater than 0. So type can be any valid C data type. Any valid data type can be used. Int, float, like that. Any type can be used. Valid C data type can be used. So example, double balance of type. This means balance is the array name and double is the type of that array. So balance can store double data type and it can store 10 elements. It can store 10 elements. Okay. This is another n is another integer array which can store 10 elements. So 10 elements can be stored in n array. So how to initialize this array? So this is how we can declare array. So we have to use type array name. So that array name, we can use any array name. All the variable naming conventions can be followed here also. And within square brackets we have to specify the size of that array. If you want 100 element array, then you have to specify n of 100. Then you can store 100 elements, n of 0, n of 1, like that, n of 99. So how to initialize this array? So you can initialize this array like this: double balance of 5 equal to, within braces, if you give some 5 elements. So 1000, comma 2, comma 3.4, comma 17, comma 15.50, comma. So within square braces, you can enter these values. So what it does is, in balance of 0, so the array is 5 element array. So it will be balance of 0, balance of 1, balance of 2, balance of 3, balance of 4. So at balance of 0, 1000 will be assigned. Balance of 1, 2 will be assigned. Balance of 3, this 3.4 will be assigned. Balance of 4, balance of 2, 3.4 will be assigned. Balance of 4, 17 will be assigned. And balance of 4, 50 will be assigned. So this will be 0, 1, 2, 3 and 4. The same thing we can declare like this also. Without specifying the size also you can declare, but you have to initialize. So when you give this initialization, this means balance of 0, 1000 will be stored. Balance of 1, it will be 2. Balance of 1, it will be 2. Balance of 2, it will be 3.4. Balance of 3, it will be 17. And balance of 4, it will be 50. So 0, 1, 2, 3, 4. So without specifying the size also, you can initialize this array. So you are initializing some values also. You are assigning some values and you are storing the values in this double array. So this is what it happens. So balance of 0, it is 1000. Balance of 1, it is 2. 2, it is 3.4. The 7. It is 17. We have given as 17. So it should be 17 here and it should be 50.0. Okay. Then how to access these array elements? How to access one of the elements? So if you want to accessing is done by indexing the array name. So if we want to take the last element, it is balance of 4. So if it is a 5 element array, then the last element will be balance of 4. So you have to remember that the first element starts at index 0. Balance of 0, 1, 2, 3, like that. And the last element will be n minus 1. So if it is a 5 element array, it will be 4, balance of 4. So this will index the last element. The balance of 4 means balance of 4 here it is 50. So 50.0 will be assigned to DA, this variable. So we can access any element using this indexing mechanism. So we will see an example, another example. So here we are declaring an array float mark of 5. So this means mark of 0, mark of 1, 2, 3, 4. So it is a 5 element array. It will start with 0 and the last element will be mark of 4. Okay. Now arrays have 0 as a first index. It is not 1. You have to remember this thing. The first index, that is marks of 0, is the first element. It is not mark of 1. It is the second element. Okay. So arrays have 0 as the first index and not 1. If the size of an array is n, so here the size is 5. So to access the last element is this one. The n minus 1 index should be used. Since it is 5 element array, 5 minus 1, 4 should be used. Marker 4 should be used to access the last element. Suppose the starting address of mark of 0 is 2120. If this is at 2120, since it is float, it will be using 4 bytes in your compiler. So address of mark 1 will be at 2124. So mark 0, it is at 2120. Next element will be at 2124. Then the following element will be at 2128. Like that it will go on. Okay. So this way the addressing will be, it is in contiguous location. 2120, 2124, then 2128, then 2132, like that it will go on. So how to initialize an array? We have already seen how to initialize an array. This is one method, mark of 5 equal to 19, 10, 8, 17, 18. So mark of 0 will be 19, mark of 1 will be 10, mark of 2 will be 8. Like this we can initialize an array, or like this also we can initialize without specifying the size here. So automatically 5 element array will be initialized. So this will be the thing, the mark of 0, it will be 19, 10, 8, 17 and 9. Okay. So how to change value of array elements? If I want to change some value from this, if I want to change this value, how to change it? So it is simple. If I have an array like this, if I want to change make the value of the third element. So third element means 0, 1, 2. So mark of 2 should be changed to minus 1. So it is simple like this. Mark of 2 equal to minus 1. So minus 1 will be assigned to mark of 2. That is 8 will be changed to minus 1. So make the value of the fifth element to 0. So fifth element. So this is first, second, third and fourth and fifth. So fifth element means mark of 4. So mark of 4 equal to 0. We want to change the fifth element to 0. Mark of 4 equal to 0. This is fifth, but here it will be mark of 4 equal to 0. Then how to input? So take input and store it in the third element. So if I want to take an input and I want to store it in the third element location or third location of the array, so it is like this: scanf %d ampersand. You have to use the address mark of 2. This means mark of 2 has some address location. So we have already seen an example here. So we have already specified this address like this. Mark of 2 will be at 2128. So 2128, at 2128 that element will be stored. Okay, that's why we use the address statement. This is same as that variable, getting the variable value also. You will be using simply and of mark. But here, since it is array and you want to store it in the third element, you have to use mark of 2. Then take input and store it in the ith element. If it is an ith element, you have to use specify I minus 1. If it is ith element, you have to specify I minus 1. Okay. So it is third element, so it is 3 minus 1, it is 2. Okay. Now how to output? So if you want to print the first element of the element array, then you have to use printf %d mark of 0. Then print the third element of the array, then you have to use mark of 2. You have to print mark of 2. So then print the ith element of the array, then you have to use mark of I minus 1. Mark of I minus 1 should be used. Okay. There is no ampersand here. You already have learned this. Only for scanf you require to show the address. So before going to the exercise, I will show some examples. I have some 9 examples here. So these are all simple examples. Okay. So array 1, this is the first example. Here, whatever we have seen, it is shown here. So integer I is declared here. Then we are initializing a marks array. I am not specifying the size here and simply giving some values 34, 46, 45, 22, 11. So what happens is marks of 0, 34 will be assigned. Marks of 1, 56, marks of 2, 45, and 22 will be at marks of 3, and marks of 4, it will be 11. Now if you want to print the first element, what you have to print is marks of 0. Then last element, it will be marks of 4. So percentage D will be replaced by marks of 4. Now if I want to print the whole elements 34 starting from first, you can use a loop, for loop. So you can use a for loop like this. So since the first element is marks of 0, so I should be initialized to 0 here. So I is initialized to 0 and 0 less than or equal to 4 will be checked. It is true. So printf percentage D marks of 0. So first marks of 0 will be printed. Then I value will be incremented to by 1. 1 less than or equal to 4. It is true. So marks of 1 will be printed. Like that, marks of 4 will be printed. When I becomes 5, 5 less than or equal to 4 becomes false. So it will exit the loop. So if you run this program, you can see this gcc array1 dot c dot slash a dot out. So if you run this program, you can see that the first two elements will be printed. So first element is 34, last element is 11, and the whole array elements will be printed 34, 56, 45, 22, 11. So for printing from an array, you have to use a loop. Okay. Now we will see another example. This is another example. So it is a program to take 5 values from the user and store them in an array, then print the elements stored in the array. So we will get some 5 values from the user and we will print those 5 values. So we are declaring a variable here, array here, values is our array. So this is our array name and we are declaring it as 5 element array. So values of 0, 1, 2, 3, 4. Then printf enter 5 integers. So you are asked to enter the 5 integers, and for entering that 5 integers we are using a for loop. So you have to enter in values of 0, 1, 2, 3, 4. So you have to start with, so you can remove this. Sometimes it will show an error. In some compilers it will show an error if you declare like this. We will see whether it will show an error here if you are declaring. We will run this before that. In some compilers it will show here there's no problem. Okay, so you can declare here also. So it is not necessary that you should declare before itself. Since we are using this I only inside this loop, you can declare here itself int I equal to 0, then initialize to 0, 0 less than 5, it is true. So what it does, it will come to the statement scanf ampersand values of 0. So we will scan that element, we will get the input from that element from the user, and it will be stored at address location of values of 0. There will be some address location like 2120, some address location will be there. So it will be stored at values of 0's address location. Then after that I is incremented, I becomes 1, 1 less than 5, it is true. So again scan, it will scan for another element. So it will repeat for up to I equal to 5. So it will store at 0, 1, 2, 3, 4. So 4 elements will be stored. Now we will be displaying those arrays that we have already seen how to print an array. So you have to use a loop. Again we are using the same I variable because we have to declare again here. If you don't declare, it will show an error because this I has scope only inside this loop. We have declared only inside this. So outside this there is no I. The program doesn't know, or the compiler doesn't know about this I. So you have to declare again this I here, I equal to 0, it is initialized, and so it is not necessary that you have to declare here. Okay, you can use, you can declare here also outside whatever. If you want, you can declare here. So you can declare here itself, no need to worry. If you have confusion, you can remove this. Okay, here also you can remove this, so I'll just remove this. Okay, now it's the previous for loop itself. I equal to 0, I less than 5, So 0 less than 5, it is true. So values of 0 will be printed. So whatever you have stored in values of 0 will be printed here. Okay. So we will run this program. So this is just to get the input and output, input from the user. So you will be asked to enter 5 integer values and you will be storing using the scanf. Okay, scanf, you have to learn this. So you have to manipulate, when you have to manipulate this array, you have to enter using a for loop, and also for output also you have to use another loop. Okay, now I have already compiled this program. So dot slash a dot out, you have asked to enter for 5 integers. I am entering 45, 56, 12, 34, and 67. Now all the numbers will be displayed: 45, 56, 12, 34, 67. So the first for loop will scan and the second for loop will print the whole numbers. Okay. Now I will take another example, array 3.c. So this is another example. So we have already done this for some for why using why when we studied while loop, we have done this program. So you have to find the average and sum of n numbers. So actually it is sum and average of n numbers. So you are storing n numbers in an array and you will try to find the average of this. For example, if I want to get the average marks scored by the whole class, I have to enter 60 marks and store it in an array. Then I will find the average of all those 60 marks. Okay. So the same program. So in main, here I am declaring an array marks of 100. So you can store up to 100 elements. It is not necessary that you have to store 100 elements. You can, that array is capable of storing 100 integer elements. Then I am declaring in and sum equal to 0. Some variables I have declared, sum equal to 0, and you can declare average also equal to 0, let it be. Average also initialized to 0. Now printf, enter number of marks. So how many marks you want to enter? You want to enter 60 students marks, then you have to enter n value as 60. If you want to enter 10 students marks, then the n value should be 10 should be entered. Now what you are doing is you have to enter those marks. For that we have to enter in the scanf statement. So for I equal to 0, I less than n plus plus I. So for I equal to 0. So initially I is n is, let it be, we are entering only 5 marks. So I equal to 0, I 0 less than 5. It is true. So enter. So this is just simply to print. Enter mark percentage D. So percentage D will be replaced by I plus 1. So I is 0. So enter mark 1. So mark 2, enter mark 2, enter mark 3, enter mark 3, like that. If you want to print, you can use this statement. It is not necessary that you have to use this statement. This is simply to print that enter mark 1. So enter mark 1 will be entered and that mark will be stored in marks of 0. The first mark will be stored at marks of 0, scan of marks of 0. Then after that, sum will be found. Sum is initially 0. Marks of 0 will be added. So whatever you enter will be added to sum and it will be assigned to sum. After that, I value will be incremented to 1. Then 1 less than 5. It is true. Again, enter mark. Here it will be I plus 1. That is mark 2. Enter mark 2. Then scan ampersand marks of 1. So it will be stored in marks of 1. Second mark will be stored and that marks of 1 will be added to the previous sum and it will be assigned to sum. Like that it will go on repeating. If you enter 5 element, then when it becomes 5, it will exit the loop and then it will calculate the average equal to the sum divided by n. Then print of sum is also printed here. Sum equal to percentage sum is printed here. Average equal to percentage D and average is also printed here. So I will run this program gcc array 3.c. Now if I compile this, enter number of marks. So I want to enter 5 students marks. So enter mark 1. So this is to print mark 1. So enter mark 1, I will enter as 23. Enter mark 2, it is 34. So this will be stored at marks of 0. This will be stored at marks of 1. And this 45 will be stored at marks of 3. Then I am entering marks of 4. This will be stored at marks of 3. Then I will enter 56. So this will be stored at marks of 4. So this, even though it is marked 5, it is printing, it will be stored at marks of 4. The sum is, the total sum of this marks is 225 and the average it is 45 marks. So the average of this thing is 45. Okay. Now I will show another example, array 4.c. So this is another example here. I have declared an ARR. The array name is ARR, and and it is size is 5 element. So ARR of 0 is there, 1 is there, 2 is there, 3 is there. Now when I am assigning some values, ARR of 0 is assigned as 5. Now ARR of 2 is assigned as minus 10. I am assigning minus 10 to ARR of 2. Now I am assigning ARR of 3 by 2. So what is the, this is 3 by 2 is actually 3 by 2 is actually 1.5, but 1.5 will be replaced by 1. So this 2 will be stored at array location ARR of 1. So this is same as writing ARR of 1. So even though we are writing 3 by 2, this is same as writing ARR of 1. Okay, so you can use like this indexing also. Only thing is it will take only integer indexing. Even though you have given 3 by 2, it will be taking only as ARR of 1. And ARR of 3 equal to ARR of 0. What it does is ARR of 0, whatever that is in ARR of 0, it is 5. That will be assigned to ARR of 3 also. Now we are printing all those values. Percentage D, percentage 4, percentage D. So first percentage D will be replaced by 0, second by ARR of 1, and third by ARR of 2, and fourth by ARR of 3. So we can run this program and see gcc array4.c and dot slash a dot out. You can see 5, 2, minus 10, and these two elements are assigned same values. Okay, so this is also possible. So this type of assignment is also possible. You can assign a particular array value. So ARR of 0 is 5 and that will be assigned to ARR of 3. So these two will contain the same value, ARR of 0 and ARR of 3. And this will be replaced by ARR of 1. So if you check the value, you can see that it is assigned to ARR of 1 is 2. Okay. Now I will show another example, array 5.c. These are all simple examples. So see here in this example there is some problem, but it compiles even though it is out of box. So I have declared an array of 2 elements. So ARR of 0 and ARR of 1 is there. But what I am doing is I am printing percentage %d ARR of 3. Actually it is not there. ARR of 3 is not an element here. And I am printing ARR of minus 2. So we will see what it prints. Okay. So I am declaring ARR of 2 and I am printing ARR of 3. So this is actually out of bound. We have only 0, 1 element, 0 and 1. There is no ARR of 2 or ARR of 3. But we are trying to print ARR of 3. Similarly, it is ARR of minus 2. We will learn about this minus 2 later. Now you learn this example. Just see this array 5.c. So there is some problem here. We have not declared here. So there is some warning here. Two warnings are actually generated here. We have, because the elements are not there. In some compilers, this warning won't be there. Okay. Here anyway, it has given some warnings here. If you compile it also, these are just warnings, these are not errors. So you can see that we are printing those two values. So actually it will give some garbage value like this. Some garbage values will be given like this. We will learn about this minus 2 later. Okay. Now I will show another example, array 6.c. So this is another example we have already seen. So we are declaring a two size array, but we are trying to store 5 elements. We are trying to store 5 elements in a 2 element array. So we have actually only ARR of 0 and ARR of 1. But we are trying to store 5 elements. So what happens? And we are trying to print all these things. ARR of 0, ARR of 1 and ARR of 4 also we are trying to print. So here we can store only actually 2 elements. 10 and 20 will be stored. All these things will not be stored and it will have some problem here. So we will see that. Let me clear this GCC. So it was actually error of 6.c. Okay. So here it is showing some warnings. It is not error. Excess elements in array initialize error is there. And when you try to print index 4, ARR of 4, there is also another array. But these are all warnings and you can run this program. But you can still run this program. You can see that first two elements, percentage D, ARR of 0 and ARR of 1, there is no problem. 10 and 20 will be printed. And ARR of 4, it will print some garbage value. Okay, it will print some garbage value. So those elements are not actually stored because only two elements can be stored in this array. Okay. Now I will show another example. So this is another example just to show that the array elements are stored in contiguous location. I have already mentioned that all the array elements will be contiguous location. That is, if it is an integer array and if it is using 4 bytes, first element is at 2000, then the second element will be at 2004, 2008, 2012, like that it will be going. So in order to show that, we are going to show a program. You leave these comments. You can see that I have declared an array here of 5 element array, and your size of integer of this compiler, I am trying to print the size of this integer. Size of int will be printed here, and inside this for I equal to 0, I am trying to print the address of all these elements. Address of 0. Address of 0 is percentage %p can be used to print the address. We have already seen this thing. And I will be printing I is actually 0, ARR of 0. So this percentage %d will be replaced by I value. So the first element 0 will be replaced, and ampersand ARR of I will be the address of that element. Ampersand ARR of 0, that address will be printed. Then it will continue, all the 5 address locations will be printed. We will see whether there is an error in this. I will clear this GCC ARR7.c. So there is no error. Now if you compile this, you can run this, you can see that ARR of 0. So the size of this integer in this compiler is 4 bytes. It will take 4 bytes. So the first element ARR of 0 we will take the last two elements 20. Since it is using 4 bytes, ARR of 1 will be at 24. Then the next element at 28. After that it is 32. So 32 it is actually 2C. It will be hexadecimal value, it will be 2C, and after that the next element will be, so it will be in contiguous locations. It will be, so first element, all this will be in continuous locations. So that's what I want to show, just to show that thing. Okay, you need not study about this thing. So this program is actually just prints that thing. So prints the address also. We are trying to print using the percentage %p. Percentage %p is the address point. Okay, just to show that it is in continuous address location. Okay, now I will show another example, array 8.c. So this is an example to convert a decimal number to a binary number. So you want to convert a decimal number to a binary number. So I have already taken how to convert a decimal to binary in the class. So you have to repeatedly divide by 2. You have to repeatedly divide that decimal number by 2. So here I am using an array A of 20, then I am declaring some variables IMNR. So you are asked to enter the decimal integer and it will be stored in n. So if you enter some decimal number, that will be stored in n, and simply assigning that n to m also. It is simply to print that value, because that n value will be changing inside the program. I want that m value to be printed here. So what is that decimal m should be printed here. For that I am using this assigning, simply storing it in some other variable also. N is stored in some other variable also. Now you know what to do, how to convert it. You have to repeatedly divide by 2 and get the remainder. You have to store that remainder in some array. So I equal to 0 And if it is n greater than 0, if I have entered 25, so n 25 greater than 0. So what it does is 25 more 2 will be done and you will get a remainder 1 that will be stored in R. That remainder will be stored in A of 0. So the first element will be A of 0. So the first element will be A of 0. Then you are dividing it by 2, n by 2, that is 25 by 2, you will get as 12. 12.5, but you will get only 12 because integer division is there. 12 will be there. Then I value is incremented. I is becomes 1. Then 12 greater than 0, it is true. Then R 12 more 2, it is 0. So it will be stored in R. That 0 will be assigned in A of 1. Then again you will be dividing 12 by 2, it is 6. Then you will be incrementing I value by 1, I becomes 2. Then 6 greater than 0, it is true. Again it will come here, 6 more 2, it is 0, remainder is 0. So that remainder will be stored in the next array location. Like that it will be stored in the array location. Now you have to print it. In order to print that, you have to reverse this array because you should read from bottom. We have already seen. You have to get the remainder and finally when it reaches 0, it will stop. But you have stored in A of 0 is 1. After that A of 0 is 0, 0 like that 1, 0. But you have to reverse that array. You have to reverse that array. Then only that result will be correct. So for that you can use this loop. Now finally I will be having one value, so you have to reduce that index. Since you will be incrementing it and checking here, it becomes false, so I will be plus 1. So you have to decrement that I value first. I will be initialized to a value less than the previous I value, and you are checking whether I greater than or equal to 0. So you have to repeat up to 0. So all a of if we have 5 elements in this array, if there are 5 elements in this array, so the last element will be 4. I will be 4. So a of 4, a of 3, a of 2, a of 1, a of 0. Like that you have to print in the reverse order. So for that you have to start from the previous I value. So if that is 5, if that is 4, I would have been 5 here when before checking this condition. I would have incremented by 1. So you have to reduce it to I to 4. Then you will be checking 4 greater than or equal to 0. It is true. So what it does? So A of 4 will be printed first. Then I minus minus. So I will be reduced to 3. 3 greater than or equal to 0. Next A of 3 will be printed. After that A of 2 will be printed. After that A of 1. And after that A of 0 will be printed. When I becomes minus 1, this condition becomes false and it will exit. So you are doing this and storing it in array, and you have to reverse that array. Then only your result will be correct. So I have already taken how to convert this by decimal to binary in the class. Okay, I will run this program. GCC array a dot c. Now dot slash a dot out, you can get the output. You can enter any number. So if you enter 25, the equivalent decimal number, a binary number will be printed. 1 0 1 1 0 0 1 will be printed. Okay, so you will be actually the array will be containing a of 0 as 1, a of 1 as 0, a of 2 as 0, a of 1, like that. Now you have to reverse that. So you have to start from the last element. For that you will be printing in the reverse order. Okay. Now I will show one more final example before I conclude this session. So this is another example. This is for linear search. So you can refer a previous video lecture where I have explained about linear search, binary search, and also about bubble sort. So you have to do all these programs. That's why I am explaining this linear search also. Linear searches, you will start from the first element. You will check whether that element is present. Then you will check with the second element, third element, like that. It will be searching. You have already explained this linear search. So we are declaring an array of 30 elements in I, and we are declaring some variables key, and we are using some variable found, and it is initialized to 0. So user is asked to enter how many numbers. So how many elements you are going to store in the array. You can enter 10 or 5 elements. Let it be 5 first. Then you are asked to enter the array elements. For this, we have to scan and store it in the array. For that, we are using a loop. So A of 0, A of 1, A of 2, A of 3, A of 4, you will be storing 5 elements. After that, the user is asked to enter the key to be searched. So it is a linear search program. So you have to search whether some element is present in this array. So ampersand key. So you will be entering that key value. So you will be entering some value, maybe 25. You want to search whether 25 is present in that array. So you will be entering 25 as key value. Now again you have to go through the array. So I equal to 0 to n. Now you have to check each element. A of 0, you have to check first element and whether you have to check whether it is equivalent to key. If it is equivalent to key, you can print that found at percentage, found at that 0th location, and you can make it as found equal to 1. So if found equal to 0, then not found. That element is not found will be printed. So you will continue execution until you get that found. You will go on finding whether that element is present or not. Okay. So this is linear search. So you have to store that all the elements in the array. Then you have to get a key value which is to be searched, and you have to use this loop. You have already seen this thing, so you have written algorithm for this already. So you have to check for each element. A of 0 will be checked with the key, then A of 1 will be checked, A of 2 will be checked, A of 3 will be checked, A of 4 will be checked. If you get any of this element is equal to, then you will stop, you will print that found at that location, and you will set the value found equal to 1, and again you will continue executing this loop. If there are two same elements that is stored in the element, you both those locations will be printed here. Okay, I will run this program, then you will understand why. So I'll clear this gcc array9.c. Now dot slash a dot out. So you will be asked to enter how many elements you want to store the element array. So I will enter 5 array elements. So I am asked to enter some array elements. So I will store 89, 34, 67, and again I will enter 89 also. Then I will enter 32. So I have to I have to enter some value that is to be searched from this array. So I will enter 89 itself. So I have entered 89 two times. So it should be found at 0th location and 3rd location. So found at 0 and found at 3 will be printed here, because 89 is present at two locations. So it won't stop at the first element. It will again go through the array and it will check whether any other element is present. You can check for another elements. So I am entering some other 23, 12, 34, 56, 78. Now if I will check for some element that is not present, I will enter 10. So 10 is not entered, so not found will be printed, because that found value was initially 0 and that value won't be changed. So if found equal to 0 will be true, so not found will be printed. Okay, not found will be printed. So this is linear search. Okay, now I have given a few exercises also. For only 5 programs are there. You can easily do these programs. So you have already done this program when you studied while loop, but now you have to use arrays to do this. So read n integers, store them in an array, and find their sum and average. I have already shown this in the lecture. Then read n integers, store them in an array, and search for an element in the array using an algorithm for linear search. We have already seen this program. I have already explained this linear search algorithm. So you have to do the same program here. If you want about linear search, I have already uploaded the video about linear search when I taught you in the first module. Then this is the third program, read integers, store them in an array, and search for an element in the array using binary search. So binary search also I have explained in the previous lecture. You can refer that lecture. Then read an integer, store them in an array, and sort the elements using bubble sort. So bubble sort algorithm I have already explained in the previous when I taught about algorithms. I taught this bubble sort also. So for bubble sort you will require for loop, nested for loop will be required. You require two for loops. So one the outer for loop, you will take first element, you will compare with the second element, third element, fourth element, like that you have to compare. So you need a nested for loop in the case of bubble sort. Then we have already seen this program, convert a decimal number into binary number using an array. I have already shown that program. So you try by yourself. All these programs you have to try by yourself and you have to do this exercise. Okay. Thank you.